In our previous video, we came up with the solution to the second example problem and calculated a yield of 5.63 grams of H2O. So, suppose that we went into the laboratory and carried out this reaction from example number 2. We react 5 grams worth of ethylene and 15 grams worth of oxygen. But in our reaction, we only produced 4.5 grams worth of water vapor, rather than the 5.63 that we predicted. What happened in our experiment? Did we go wrong somewhere, or is this an expected result? It's rare that actual reactions or experiments go perfectly according to plan. That's because our ability to make measurements and to carry out reactions thoroughly without making any side products, like in a combustion reaction, soot from incomplete combustion, isn't always possible with perfect precision. When real experiments don't go according to plan or produce as much stoichiometric product as we would have predicted, that's okay and no reason to fear. It's because of our inability to make perfect reactions. As a good gauge for how far off we've strayed in our actual experiment from our theoretical predictions, chemists often produce what's called a percent yield to describe how much we've made compared to what we expected. A percent yield is the ratio of what we actually get from an experiment when we carry it out to what we thought we should have gotten from our calculations, multiplied by 100 to give us a percentage. It's the actual yield divided by the calculated theoretical yield, multiplied by 100. Given the previous problem then, if we actually carry out this combustion reaction and produce just 4.5 grams worth of water vapor, what is the percent yield of water from this reaction? The percent yield is given by an equation, actual divided by theoretical yield, multiplied by 100. In our example here, 4.5 grams worth of water actually produced when we carry out this experiment is the actual yield. And our solution to this problem, the 5.63 grams of water we calculated on the previous set of slides, was our theoretical yield. Therefore, our percent yield is actual 4.5 grams divided by theoretical 5.63 grams times 100. It doesn't matter what units we use for the numerator and denominator in this calculation, so long as they're the same. All we need to do is be consistent with units so that they'll cancel out and just give us a percentage anyway at the end. Here, we're using units of grams for both the numerator and denominator. When we divide 4.5 by 5.63 and multiply by 100, we get precisely 80 to 2 significant digits. I'll place a decimal point right after the 0 and 80 to keep 2 sig figs. Therefore, our percent yield for this reaction is 80%, which is actually quite good compared to many other chemical reactions.